In this video, we're going to review solving absolute value equations. Now, at the top of the screen, you'll see isolate the inequality. First thing you want to do, create two cases. I'll show you how to do that, and then you're going to solve each case. You can have up to two answers for each inequality problem that you solve. You cannot have more, but you can have up to two. So it is very important that you always check your answers, because if you can have up to two answers, you could possibly end up with one answer. You could possibly end up with no solution. So it's always a good idea to check those answers and make sure that they are valid to make the left side and the right sides equal. So in this particular case, the first thing we do in number 9 is isolate the inequality. Or the absolute value, I should say, not the inequality, but the absolute value. So our absolute value is isolated. Second thing we're going to do is we're going to set up two scenarios. We're going to completely drop the absolute value symbols, and the first scenario is just the equation without the absolute values. So negative 2 minus 10w equals to 98. Now, the second scenario is that you always make the side of the equation that does not have an absolute value, you change its signs. So we're going to keep the negative 2 minus 10w, but we're going to change that 98 to a negative 98. And that is your two cases. Now we solve both cases, and then we'll have to check our answer. So I'm going to add 2 to both sides. That gives me 100. When I divide, I get negative 10. Here, I'm going to add 2. That gives me negative 96. And when I divide by 10, I get exactly 9.6. Now, if you want to leave it as 96 over 10 reduced, you can leave it in fraction form. But since this divides out perfectly to 9.6, I did not round or anything like that, then I can keep it. If you plug both of those numbers in to the original problem, they will satisfy the given absolute value equation. So I can write those down as my answers. Now notice that I used braces. I did not use brackets. I did not use parentheses. I used braces. Braces indicate that those are the only two numbers that are solutions to this problem. So anything you put inside a set of braces indicates what the answers can be. In number 10, when I isolate the absolute value, I have to add 6 to both sides. So the 6 has to go to the other side before I can set up my two cases. So I have the absolute value of 2b equals to 20. Now I'm going to set up my two cases. My 2b plus 4 equals to 20. The first case is just drop the absolute value symbols. The second case is to change the side of the equation that did not have the absolute values to the opposite of what it was. Now I'm going to solve both of these. I'm going to subtract 4, and I'm going to divide by 2. I will subtract 4, and I will divide by 2. So my answers for B are negative 12 and 8. If you plug both of those back into the original absolute value equation, you will find that the left sides and the right sides balance. Now, a lot more I have to do with number 11 and number 12. I'm going to isolate the absolute value. This time I need to divide both sides by negative 4 to get the absolute value of 7 minus a. That gives me positive 9. So I'm going to set up my two problems once I get my absolute value isolated. So 7 minus a equals to 9, and 7 minus a equals to negative 9. Notice I am only changing the non-absolute value number. So here I will subtract 7, which gives me -2, and divide by negative, so I end up with A equals +2. I apologize. I do not. Let's try that problem again. I will subtract 7, and I will get +2. Divide by negative gives me -2. I will subtract 7, and I get -16. Divide by negative, I get +16. If I plug both of those values back into the original problem, they will both make the left and the right side of the original problem balance. Now, number 12 is special because we're going to come up with a different type of answer. We're not going to come up with two answers, which is the maximum number I can get for an absolute value problem. So in my process, I have to isolate the absolute value. So I'm going to add 9 first. That would give me -34 equals 2 times the absolute value of 6 plus 8k. Then I'm going to divide both sides by 2, and I get -17 equals to the absolute value of 6 plus 8k. Now, absolute values cannot equal to negative numbers. So I have an absolute value equal to a negative number, so there is no solution for this problem. Now the 0 with the slash through it, if you remember, that does indicate that there is no answer to a problem. So either one, the 0 with the slash or the no solution. Now, those of you that like to write your zeros with the slash through it, please be mindful that that also indicates no solution, and that's how I see that particular image. The last two problems that we are going to do, 13 and 14, because I think this will be enough to kind of get the point across. We're going to, in number 13, isolate the absolute value. So I'm going to subtract 1. That gives me -10 times the absolute value of 9r plus 3 equals to -30. I'm going to divide both sides by -10. That gives me 9r plus 3 equals to +3. And then I'm going to set up my two equations. 9r, drop the absolute value, 9r equals to 3, and 9r plus 3 equals to -3. I'm going to subtract 3, so that gives me 9r equals to 0. So r equals to 0. Subtract 3, I get 9r equals to -6, and r equals to -2/3. If you plug both of the answers into that original problem, they will satisfy the given problem, and they will make the left sides and the right sides balance. Now notice in number 14, I don't have a number, just a number like -29 or something like that. So when I set up the problem, I go through my thoughts. My absolute value is isolated. When I go to set up the two cases, I'm going to drop the absolute value, and I'm going to keep the problem with all the signs as they were. In the second scenario, I'm only going to change the right side, which was the side that didn't have the absolute value. So I'm going to make that a -3a and a +10. Everything has to change, not just the 3a. Now I'm ready to solve my problem. I'm going to move 3a to the front and 8 to the back. I'm going to do 2 steps in one. So 2a equals to -18 and a equals to -9. Here I'm going to do the same thing. I'm going to add the 3a and I'm going to move the 8 to the back. So that gives me 2a equals to 2. I'm sorry, that does not give me 2a. That gives me 8a when I add, not subtract. So a equals to 1/4 when you divide both sides by 8. Now, this problem has 0 solutions. Watch what happens when I plug -9 into the given problem. So I'm going to have to come over to the left-hand margin. So that would be 5 times negative 9 plus 8, all in absolute values, equals to 3 times negative 9 minus 10. On the right-hand side, I get negative 45 plus 8, which is the absolute value of negative 37, which is 37. On the right-hand side, I get negative 27 minus 10, which is negative 37. A positive 37 and a negative 37 are not equal, so therefore, negative 9 is not a solution to this problem. You will also find that when you plug in negative or positive 1/4, it will not balance the left and the right sides. So I hope this helps you kind of go back over and review your absolute value rules. So if you have any questions, please make sure that you contact me.